Okay, so I'm just about halfway done with the spite testing. You can see these are all flashed and tested. I thought, I will make a little video before I've run all out of boards. Show the process a little bit. So yeah, the boards, they come in panels like this. Let me zoom in a bit. All right, and on the bottom I've added test points for all the major functions. So mostly I've broken out flashing pins as well as the interconnect, motors, power, and this is so that these test points on the back can be probed by these pogo pins. And what these are, they're basically spring loaded spring-loaded contacts that I've socketed into this PCB so that if any issue happens, like if they break or bend, I can easily replace them. And so yeah, for the test jig, I've designed this PCB board that breaks out all these pads out to a header so that they can be easily accessed by the flashing tools. I've also broken out the boot button along with the interconnect that you can see right here, so that simulates, well, it basically reproduces the way the boards are connected when they are married up together. And I've also have little LEDs to indicate all the power rail status. I have some MOSFETs here to switch on and off USB and main power, along as some MOSFETs here to commutate, to remotely boot the pins as well from the header. So yeah, I've assembled this. I've created this. The pogo pins are soldered into this, and then in order to locate the PCB, the boards into it, I've printed this this frame with so this frame locates it, the PCB, and I've added these features on the bottom that push on the PCB in some key areas. And I guess we can already proceed with latching this one in. Boom, put it in there. Wow, there you go. It doesn't look like it, but there is 50 of these pins, and they amount to quite a bit of pressure, and so I had to add some way of reinforcing the latch, the door, in order to avoid it bowing. It was literally bowing, and that caused some contact issues. So I've just glued this carbon fiber prototype on it rather than print another one, and that's been working pretty well. There's a lot of botch on this test jig. That's my first one. You can kind of expect that, I suppose. The USB-C that was supposed to get there, I ordered the wrong connector, so I just broken out one of the spite USB micro, and for the video I initially used a VTX, but then we thought that maybe it would be more appropriate to use a AV out. So I've just took this AV out from an old PC, literally desoldered it because I had it at hand, and since it was broken out to the header, I could just plug in directly and it goes out to the monitor right here. And likewise for the motors, yeah, I wanted to make hole patterns onto the jig. I forgot, so I had to tape them in place. But in the end, it might not look pretty, but yeah, it's been working pretty well for the first half of the batch. So yeah, let me walk you through it. So right, here's the script that we've made together with Hanfer, mostly Hanfer from Quicksilver, and yeah, it automates the whole flashing of the board. So there are six microcontrollers to flash. So there is the flight controller, Express LRS receiver, and the four ESCs. On top of that, we're also flashing the OSD chip with the right characters. So that's really 7 flashing procedures. And likewise for Express LRS, we are flashing it twice. We are flashing it once with production firmware that has my bind phrase on, so that I can verify that it's outputting properly, that the receiver is working, and then it flashes the final firmware that has no bind phrase, so that yeah, you can bind to it directly. So yeah, let me walk you through it. So here I'm just gonna press enter to get started. Oh yeah, first I need to apply power. Boot power. So we have the camera that comes to life. I've also put some piece of transparent PETG here to that go directly to the LEDs on the PCB, so that I can see it from outside that the LEDs are working. And yeah, we just enter and it gets started. So boom, it starts with Express LRS. Test firmware. Here it asks me to confirm for bind. And boom, we're bound. We have a solid Express LRS light, which is good. Press enter. Now it's gonna flash the final firmware. Done. Now it's the ESC 1, 2, 3, 4, and we are flashing the bootloader, the firmware, and even the settings at once. So that's pretty cool. You don't need to get into your settings and adjust the KV or remove the stall protection, motor startup stall protection. So it comes pre-configured, ready to run. So now the FC is already flashed. Now we are sending a few commands by CLI to the FC to set my OSD elements, so that I can verify that the OSD chip is working fine. Right now it's updating the OSD characters. And boom, we have OSD. Everything's looking fine. The script asks me to confirm, which is a yes. And then we move on to motor testing. Motor 1, motor 2, motor 3, motor 4. Enter each time. And that's done. That's our FC complete. Turn off power. And there you go. Takes about 2 minutes to complete, a bit less than 2 minutes to complete the process. So we do all the flashing and yeah, most of the testing. So at least we can make sure that every FC that gets into the box at least has working video, it has working receiver, it has working flight controller, and most importantly, it has working motors. And yeah, so this was the minimum implementation of a test jig we could do for this tiny of a batch. This first batch is 50 units. So that's pretty fine for that. I can probably do quite a bit more even with this setup still. But yeah, if we end up doing any more, we're gonna need something a bit less janky. But for now, I think that's pretty good. We're testing a lot of vitals components, and we are delivering a pretty good flight controller with everything flashed on and basically ready to use. So yeah, hope you found it cool, and I'll see you around. Cheerio.